So, good evening, everyone. My name is Pallavi Verma, and I'm currently pursuing Masters in Data Science from UWA. So, I'm currently in my second semester, and I'm using R from past 7 to 8 months. In two of my units, I have used R in statistics and data science. So, today I'm going to present you tidy data in R, how to actually make data tidy. Um, let's get started. So this is the data science sequence steps, which actually flows while we are actually dealing with data. So while we have data, what actually we do with the data? First, we import the data, and then we directly try to make that data into a tidy format so that we can visualize or do some transformations, do some modeling, and bunch of stuff on that data. But before that, we have to make sure that our data is not messy and it is tidy enough to actually visualize the correct data. And these are the sequence steps which I have taken from R for Data Science practical book. And so now today we'll be studying tidy data. So what is tidy data actually? So any data that can make our analysis simplify or easy, that is known as tidy data. And the data, when we import the data, it can be of any form like text file, a CSV, data from HTML, JSON file, or many other different stuffs. But when we import that data into a table, it forms a data set, and that is stored in a table or file in our language. And in that table, if we see, we have certain rows and certain columns. So all the rows are known as observations and all the columns are known as variables. So these are the terminologies which we'll be using very frequently, and that's why it's very important to know the meaning of observations and variables. And in the values on the right hand side, we can see that each attribute of the data table is known as a specific value. So we have observations, we have variables, and each of the attribute is known as value. Um, so next, what is a tidy data looks like? So probably when we import the data set, we can't figure out what actually the data means, or like we have rows, we have columns. Why we actually want to make it more tidy, or what's the actual meaning of making the data tidy? So these are the few steps we can see directly when we look at the data. That is our data well good enough to actually perform some visualization or not? So if, for example, headers, like headers contain some value instead of categories or names. Let's suppose we have header names from 1 to 20. So does it make any sense? No. So that's why we would definitely like to make our headers more meaningful so that we can actually use them to make our data tidy and visualize as well. Some other examples are columns may contain one set of data, more than one set of data. It's say, for example, like the column name is country, and the data in that is Perth, Australia. So it doesn't go with the variable form. So we need to clean that or make it meaningful. So let's see one example data set. So let's suppose this is a data set we import and we see, okay, these have the column names as variables and names. Um, we have observations, we have good variables, but is this data tidy or not? Like, what are your views about this data set? So for number of rows we can say are quite redundant. So we have just one information and the only thing changing in this data is here. And anything else? You can see the headers like country looks very meaningful and you can say age, but EP, REL, FN, and all the values in these columns are empty. So they are missing as well. And then
So I would, sorry, I wouldn't recognize those ones constantly. But I recognize it as referral. As a missing value. Yeah, that's okay. No worries, missing value.
so the columns are redundant, the headers names are quite odd, and many of the data is missing in this data set. So this is actually an example of a messy data, so which we would like to clean. Okay, to get started to make our data tidy, we need tidyverse. That's the package which includes three of the main libraries, that is dplyr, tidyr, and lubridate. So dplyr is for manipulating data, that is for subsetting or summarizing our data, and we'll do this in more detail just now. And tidyr, that is for reshaping the data, and lubridate is working with dates. So these are the three main packages which are included in tidyverse only. And to install tidyverse, we can just type install.package and in the brackets tidyverse, and then to call that this package we just write library and tidyverse. So um, this is how we start. And so dplyr, tidyr, and lubridate are the three packages which you don't need to install explicitly. If you install tidyverse, then these will be installed automatically. But if you need to use them, then you need to call these packages as well. That is like library in the brackets dplyr, tidyr, or lubridate. Like whenever you are trying to use the functions of these packages, then you have to call that, but you don't need to install because it's already installed via tidyverse. Okay, so if you have your own data sets, then you can load the data. So this is the data which I'm currently using for this presentation. It's sleep analysis of sleep of different animals data, and this is the data which looks like we have name, um, genus, order, and what's the total sleep time for every animal. Some have the NA values as well. So let's work with this data now. So so we are starting with dplyr package firstly. And some of the most used functions used in dplyr are select, filter, mutate, group by, summarize, arrange, join, and find. So we'll go this one by one. Um, so firstly, select. Select is used to actually just pick few variables from our data set. Suppose we have like 50 columns and we just wanted to pick like 4 or 5 of them. Then what we can do is just use the select function, and in the brackets, first we have to mention the table name, and then that's the table name, and then we have to mention the column name separated by comma. So that's the simple syntax for using select statement. And then we can store this into another data set, which will contain only those columns. And we can use head to just display the first 6 rows of that data set. So is everything going fine? Okay. So next come, we have multiple ways to do select as well. So this is one of the way where we just mention the table name and multiple columns selected by separated by comma. But what if we have like we want 48 columns out of 50? So we want to exclude two columns. What we can do is we can use the subtraction symbol in front of the column name. That is, for example, here in the first example, I mentioned the table name and then excluded the name column explicitly, and then it just displayed all the other columns except name. So this is another feature to another type maybe to use the select statement. Another can be like you want a certain set of columns. So in this example, let's say we want name, genus, war, and order. So if we want just these four columns, we can use the colon symbol to actually put from name, colon, order. So that specifies the range of columns we want from the data. And another is like starts with. So we specify the table name and then specify the column name starts with A, B, or some other characters like maybe SL in this case. And then it displays the three columns that starts with SL. So these are some of the ways in which we can actually extract the column names from the data. Now, next is filter. Filter is actually to filter out some of the rows which we want or which we want to actually visualize something. So it may be like we have a customer data and we just wanted to look on those data, those customers which have age greater than 30. So we'll just subset the data and use filter here. What we'll do is just use the filter function from dplyr and then specify the table name and then your condition. So this is the condition sleep here in this case I have used the sleep total of the different animals that is greater than 16. So which of the animals sleep greater than 16 hours in this case? And we can use multiple filters as well. So this is like if you want uh, uh, let's say we want to work with strings, so we have the order variable which is of data type string, and we want to use two values, uh, primates and something something, and then we want to use another variable that is body weight that is greater than equal to 1. So this is actually using multiple filters on a single data set, and we can just use the same syntax. Filter is the function, then in the brackets you put the data table name and then your condition separated by different by comma. um, okay, and then next is these are the filter conditions. Next is mutate. Mutate is actually if you want to add one or more columns in your data set, and then in that case, uh, it's like using your own columns in the data set and then modifying those columns in to form a new column. Let's say if you want to convert the weight from kilograms to grams, you just divide by 1,000, but you don't want to actually make the changes in your original data set. So you create a new column using mutate and then make whatever changes you want to do. So we use mutate function here, and again the data table name, and then the condition you want to put on the table. So here rem proportion, that's the new name of the uh, column, which would be created at the end, and we can see here like the two new columns are generated. in those conditions, complete when there is a speed total that is the proportion of two speeds, and this is divided in grams. So in this way, we are not actually modifying our original data set, but actually just adding new columns and modifying what we need. And then is group by. Group by is like grouping the categorical variables together. So in this case, we have one variable order which has some key values. So we can simply do group by specifying the group by function, and then in the brackets table name and specifying the column names on which we want to group by. So in this case, we have taken order, and as you can see, this yellow highlighted text, this shows the number 19. This means that order variable has unique 19 values in it. That's why it's grouped into 19 different rows. And this actually goes by a summarize function, which is coming next, which actually is like you can summarize your narrative into like median, you have to find standard deviation, first, distinct or total number of count of n variables. So that is like grouping your categorical variables together of the same name and then summarizing by maybe just counting the number of values for each. So, for example, we have 80 rows and we have 10 groups, and each group is like summarized into 10 rows. Maybe this would be more here. So, I've used summarize. That is the function that is used to summarize the uh, summarize the column, and then we specify the table name and comma the what we want to find. We actually mentioned here a new column which is average sleep, and then that is equal to mean of sleep total. So we found the mean or the average value of the sleep, and there is a new name of the column. And using summarize function, you can see that the average speed is from all the columns, it summarizes into like one value. And then we can use multiple summarize statements as well in one summarize function. So if you want like three different values giving mean, minimum, maximum, and the total number of count, then we can do that all in one summarize statement. And this is what I was telling you, that group by is actually must actually go with summarize, because when you group by, it doesn't show you except that how many the unique values it's grouped by. It just shows the actual data set. So if you use group by with summarize, it gives the summary of like we have the 19 different types of order, which that was showing a number previously. And then I calculated the average speed, minimum speed, maximum speed, and the total number of count. So for like time, there are 12 count, and this is the average speed. So that's we can actually use summarize and group by together. Then comes uh, arrange. So arrange is actually sorting the to sort the data frame on one or more columns. And you can also use arrange simply by using arrange function and then specifying the data table name and then which columns you want to sort. By default, it sorts the columns in ascending order. But if you want descending order, then you can either write DESC in front of the column name, or you can just write the negative sign. These are the two options. Pick the negative sign, very easy. And then comes join. This might go into intermediate levels, I suppose, but uh, this looks difficult, but it's quite easy from this picture they're taking. Have you used databases or SQL